Now these are different examples. Look at this first example and think about it. Now this is your chiral center which is attached to four different groups. What are four different groups? Iodine, fluorine, bromine and hydrogen. All of them are having different atomic numbers. So as we know, iodine, fluorine and bromine are halogens. And who is having the highest atomic number? Iodine has highest atomic number. So it has got first priority. Then we have bromine, then fluorine, and the least priority group is hydrogen because its atomic number is 1. Now we have given priority 1, 2, 3, 4. Now we are going to draw an arrow. This arrow is going through 1, 2 and 3 and it is moving in a clockwise manner. So your answer can be R. But how will you confirm your answer? By looking at fourth priority group. Now this hydrogen is below the plane or going away from you. So this is your final answer. R is going to remain R, means this molecule will have R configuration. Look at this second example and think about it. Now again this carbon is attached to four different groups. This is your chiral center and these four different groups are fluorine, bromine, chlorine and hydrogen. And the priority order is bromine will have first priority because it has highest atomic number. Then we have chlorine and then we have fluorine and hydrogen is again the least priority group. Then draw an arrow going through 1, 2 and 3. So can you see the direction of moving arrow? Yes, it is in anti-clockwise direction and so the molecule can have S configuration. How will you confirm this answer? By looking at fourth priority group. Do we have this fourth priority group below the plane? Yes. So S configuration is going to remain S. And for this kind of example, the answer is S configuration. The third example. We have chiral center here, which is attached to four different groups. These four different groups are hydroxy group, hydrogen, methyl and fluorine. Now the priority order is in this way. See, this chiral center is directly attached to oxygen, hydrogen, carbon and fluorine. If you draw its skeleton, you will come to know this carbon is attached to oxygen, hydrogen, carbon and fluorine. So the atom which is having highest atomic number is fluorine because it is 9. So this is your first priority group. Then comes oxygen because it is having atomic number 8. Then we have carbon. Its atomic number is 6 and then we have hydrogen. Okay, so we have given this priority. You have to always remember you have to give priority to those atoms which are directly attached to your chiral center. Okay, so I have given this priority 1, 2, 3 and 4 and I have drawn this arrow going through 1, 2 and 3. The direction of moving arrow is anti-clockwise, but the fourth priority group is above the plane. So the answer is going to change. S configuration changes to R, means this molecule is having R configuration. Now the next example. Please think about this example. Do we have chiral center here? Yes, we have chiral center here. And what are four different groups attached? These are bromine, methyl, chlorine and hydrogen. So we'll give priority. Bromine will get higher priority, then chlorine, then carbon and then hydrogen. These are four groups. Then we are going to draw an arrow going through 1, 2 and 3. So we have drawn this arrow and look at the direction of this moving arrow. It is moving in a clockwise manner. So the answer can be R. But we have fourth priority group above the plane. So your answer is not S, but your answer is not R, but it will be S configuration. So this is about general R and S configuration. Now we'll consider three special cases. In these special conditions, how you are going to assign the R or S configuration to the molecule. So this is your first case. What is the first case? When a chiral center is attached to same atom, consider its molecular weight. So look at this example. Do we have chiral center here? Yes, the carbon situated at the center is nothing but your chiral center. Why it is a chiral center? Because it is attached to 4 different groups. Can you identify what are 4 different groups? Yes, these 4 different groups are C3H7, means it is alkyl derivative of the propane. So it is propyl group. Then the next one is, it is alkyl derivative of methane. So it is methyl group. And the next one is alkyl derivative of ethane. So it is ethyl group, and this is hydrogen. So again we'll repeat, what are 4 groups attached to this chiral center? These are propyl, methyl and ethyl and hydrogen. But if we draw its skeleton, we'll have this kind of skeleton. This carbon is attached to carbon, carbon and carbon, and then hydrogen if we draw its skeleton. So how will you give priority? Because we have already said that you are going to give priority to those atoms which are directly attached to your chiral center. But here the atoms which are directly attached to chiral center are 3 carbons. So how will you give priority? Okay. So you are going to give priority according to their molecular weight. Here I have written molecular weights here. Now you are not going to consider atomic number, because all the 3 carbons which I have shown in red color will have same atomic number, that is 6. So you cannot give priority. So what you will consider? You will consider molecular weight. Here I have given molecular weights. Propyl is having 43 molecular weight, ethyl is having 29 and CH3 is 15. So how we have calculated this? For example, I'll solve for this. For CH3, for carbon the atomic weight is 12, and for 3 hydrogen it is 3. For 1 hydrogen it is 1. So for 3 hydrogen it will be 3. So 12 plus 3, it will give you 15. So same way I have solved this, and we have got 3 different molecular weights. Now these are 3 different numbers, so easily we can give priority. So which will be our highest priority group? It will be propyl group, because it is having highest atomic number. So I have written here 1. Then we have ethyl group and methyl group, and 4th priority group, that is your hydrogen. So then we have drawn this arrow going through 1, 2 and 3. It is moving in clockwise manner. So answer can be R. But how will you confirm the answer? Again by looking at 4th priority group. So this is below the plane. Yes, it is below the plane, and the direction of moving arrow is clockwise. So your answer is, this molecule is having R configuration. This is the special case which we have discussed.